Okay, so for this review video, I actually thought about it and I realized that we should, instead of doing the multiple choice, just focus on FRQs, since these are the kind of questions that you're going to have on the AP exam. So I'm going to go through with you the production possibility curve FRQ and the supply and demand FRQ. This is just to kind of review some of the things. So again, what I would do is I would try it out first on your own, then watch me answer it, and then if you still have questions, you can jump on during the office hours that I'll post for you. So the first one, the following table shows the number of donuts and cupcakes that John and Erica can each produce in one day. So they have the table here for you that shows that. So John can produce either 200 donuts or 100 cupcakes. Erica can do 150 donuts or 50 cupcakes. Now, we're going to go through and answer the questions. I'm going to answer them over here on this slide here. And of course, I left the stylus up at school, so we're going to try and see if this works here. Oh, hey. All right, so let's give this a whirl. Now, who has the absolute advantage in producing donuts? Explain. Well, remember, absolute advantage is simply being able to produce a higher number of something. So we look at who can produce the production of donuts over here. So John can do 200, Erica can do 150, and we would say John would have the absolute advantage here, right, because he can produce more. Now, who has a comparative advantage in producing donuts? Now, to do that, we're going to have to do a little bit of math, which is everyone's favorite, especially when you're quarantined, okay? So who has comparative advantage in producing donuts? So we would just simply figure out the opportunity cost. So we would say John's opportunity cost, we would come over here. All right, remember, he can do either 200 donuts or 100 cupcakes. So if he does one donut, we would just divide by 200, divide by 200, and we would say that John's opportunity cost of producing one donut is a half of a cupcake. Erica's, all right, remember, she can do 150 donuts or 50 cupcakes. So we would just divide by 150, divide by 150, and so her opportunity cost for one donut is equal to a third of a cupcake. All right, now that is, a third is less than a half, okay? And remember, the comparative advantage is all about seeing who is more efficient. So Erica gives up less cupcakes for every donut she produces, so even though John could produce more donuts than Erica, Erica has the comparative advantage in producing those. Now, assume John and Erica decide to specialize according to the comparative advantages, and that one cupcake is exchanged for 4 donuts. Indicate whether or not specialization trade are beneficial to John. So we would just go back and figure out, we know that he would produce cupcakes because he has the comparative advantage in producing cupcakes, because for every one he produces, he only gives up 2 donuts compared to Erica, who gives up 3. So if John sends Erica 1 cupcake and she sends him 4 donuts back, that benefits him, because if he were to produce donuts on his own, right, he would he would be making less donuts for every cupcake given up than if Erica sent him 4, right? Now, for Erica, that does not benefit her, because when she makes a donut, right, or if she were to make cupcakes on her own, right, she would only have to go the opportunity to produce 3 donuts. So it doesn't really make sense for her to do that. Now, it says, assume that Erica discovers a new cupcake production technique that will increase her daily production of cupcakes only using donuts on the horizontal axis. All right, draw a correct level production possibility curve for Erica. All right, so let's do that. So we would label this as Erica production possibility curve. All right, and it says to put donuts on the horizontal axis, so we would say donuts here, cupcakes there. All right, and basically she can produce, let's see, 50 or 150. That's her production possibility curve 1. All right, and she discovers a new cupcake production technique. We would shift that out and we would say that's production possibility curve 2. All right, so as long as you can clearly show that, then that'll be the correct answer. All right, and again, if you have any questions about this one, jump on the office hours and ask me. Okay, so for this one, I'm about supply and demand. I believe this is the one that we did on the test, so it should be review. You should have been able to see this before. But just in case, like I said, I'm going to go over that with you, and we will get that all figured out. All right, so it says the market for bananas and muffins are interrelated. Each market is perfectly competitive. So that means that we're going to have a perfect supply and demand market. Okay. Now, A, in the market for bananas, the equilibrium price is $1 per pound, and the equilibrium quantity is 1,000 pounds per week. Draw this market for bananas on a completely labeled supply and demand graph. Okay, so we have A there, and so we would just simply put price, quantity, and I would probably write that out more if I wasn't drawing this on the computer for you guys. We have our supply curve, we have our demand curve, equilibrium point here. Now we've already seen that the equilibrium price is going to be $1, right? And that the equilibrium quantity is going to be 1,000 pounds per week. Okay, now, so that would be the first part. B, suppose the government imposes a price floor on bananas $1.20 per pound, causing the quantity supply to increase to 1,500 pounds per week. All right, so we would just simply come up here. Oh, that one way. Draw a price floor, which is above, and we would make that straight across. At $1.20 per week. Hopefully you can see that. All right, and that would change the quantity supplied down here to 1,500. All right, right there, pounds per week. Would the price floor result in a shortage, a surplus, or neither? So that would be a surplus because that's the quantity supplied at that price and quantity demanded at that higher price. People are going to say, I don't even like bananas that much anyway, and they're going to switch and demand less bananas and buy another fruit. Okay, so that would be a surplus. That looks horrible. There we go. Somewhat better. Okay, now part C, bananas are inputs for muffins. Draw a correctly labeled supply and demand graph of the market for muffins indicating the equilibrium price and quantity P0 and P and Q0 respectively. We're going to go assuming that this is based on so we got A and B there, C. All right, we are going to assume that this was before the price floor was enacted, which I guess I should have put in the question, but all right, remember this is for bananas. This is going to be for muffins. All right, and it's the equilibrium point. Q0 and P0. Show the impact of the increase in price of bananas. All right, so remember, bananas are inputs for muffins. Okay, because we have that over here in part C, right at the top there. Bananas are inputs. So if the input price goes up, then we know that our supply curve is going to shift right there. All right, and we're going to have a new equilibrium price right there. Price 1 and Q1. It's a lot harder to do this without the stylus. So, anyway, if you guys have any questions, like I said, go ahead and log on to the office hours at the right time and ask me.